In this demo, I will show you how you can develop your multi-component application. In this case, it will be simple front-end and back-end web application. So how you can develop it directly on the cluster using OpenShift Toolkit extension in VS Code. So here I have my VS Code. I have already installed OpenShift Toolkit extension. So it's in Marketplace. So this is the one. And what I have did outside of this is that I have logged in into my OpenShift cluster. There is a whole flow which helps you log in into the cluster. Or if you already used OC or kubectl, the extension actually shares the same configuration and the same kubeconfig as OC or kubectl CLI. So if they are already working with your cluster, this will be working as well already. So now let me open my projects. So first I will open my backend. This one. This is a simple Go application, and I will also add another folder to the current workspace. It will be my UI, my web application. This is the Python Flask application. So now I will go to, so we have two directories in my workspace, two projects, two components. I go to OpenShift Toolkit view, and the first time when I want to work with the OpenShift Toolkit, I need to create a component. So I will do create component. I will choose my, for example, API. I know that my API is in Go, so I will search for Go. This basically is selecting the dev file stack from the dev file registry. I will show you more what that is later. I provide a name, so let's call it API. So now we have our component. I can create the second component that will be for our UI. This one is Python, and we will call it Simply Web. So now we have our two components. So what this flow actually did was that it downloaded the dev file into each of your project directories. The dev file is basically the description of how to build and run your application. So it tells the extension how to run the application. So now let's try to actually start the application on the cluster. So we can start with the API. We will start dev session. What this is going to do is that it will take the information from the dev file, it will translate it into the Kubernetes resources, and it will start things on the cluster. And please ignore those warnings. They are just new feature that we are currently implementing. So now you can see that it's syncing the files into the container. So what it means that it's actually uploading the source file from the current directory or from the project directory into the container that it previously started on the cluster, and then it executes build command as defined in the dev file, and then run command, and then starts the application. So now it's running. So we can do the same thing with the with the web component. So we'll do the same as well here. Again, you can see that it's syncing files and running build and run command. Now our applications should be running. So what we can do, we can check logs for our API. Let's follow logs so we know what's happening there. So now we can see that it's successfully running. For our web application, we can actually try to access it. So let's open the browser. We'll do it for port 8080. And now we see that it's failing. Which is actually okay. It's expected because right now our web application doesn't know how to connect to the backend, to the API, because it needs here you can see it needs environment variables, voting API service host, and voting API service port. So what we can do is we can go to the diff file for our web UI here, and we will add environment variables to the container. So name and value is we called our API application, and for port you can see that it in logs that it's 8080. Now before I hit save, let me go back to this terminal. We can see that when I hit save, something is happening here. What's happening is that the extension noticed that there was a change in the file, and it's automatically triggering the reload. In this case, because we defined new environment variables, it means that the whole container needs to be restarted. So it will actually stop the container or the whole pod, the cluster, and it will restart it again with new definition. If I would do just the change in the source code, it wouldn't require restarting the whole container, whole pod. This whole process would be much quicker because it would just sync the changed files, nothing else, and then it would rebuild it and restart it on the cluster. So now it's done. If I go back to application, I reload, we can see that that's our application running. It's just simple application that allows you to vote for cats or dogs. So we can cast vote for cat. There's also a result page where you can see if you who is winning. Actually change our vote, and here we can see that it updated. So what we can do now is let's try to maybe something is going wrong with our front end and we want to try to debug it. So I can go to web application and start the debug session. This is actually going to set up the VS Code debugger, and it will connect it into the remote process running inside the container. So now we have that. Let's open the source codes. We can add breakpoint somewhere. So let's, for example, let's add one here. And if I go here and try to refresh the page, I can see that we hit the breakpoint. So now I can step through the code. And I can also change the things in variables to preview that it actually works. For example, let's change the option A, cat, monkey. There's an application. Now you can see that there is a monkey. Okay, and we can also show we can also show the logs that we are actually getting requests into the backend here. You can see that okay, the vote is actually periodically updating because that's the result is fetching the information from there. If I remove this breakpoint, you can see that we post on vote endpoint, so there are actually requests coming into the backend from the front end. Okay, that's it for this demo.